Hello there, I'm Thomas Hatsios, German American about flying the Boeing 787-900 to 95 from Zurich International Airport. We're going to be able to fly Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an ILS localized and landing center. Now I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start setting the cockpit instruments, the displays, and the functions of the Boeing 787-900. The aircraft are going to start with the primary flight display. That displays the airspeed indicated, selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the radio altitude minimums on the radio altitude above the ground level, the altitude indicator with the pitch lateral decrease and the bank angle in decrease, the vertical rate of climb descent of the aircraft in 10 hundredths and half feet per minute, all the steepness of the trigonometric angles in decrease, you can climb and descend. We have the altitude indicator, as I told you, the pitch lateral decrease, the bank angle, and the artificial horizon. Also the ILS localizer, we have the horizontal localizer and the vertical glide slope displayed from the receivers from the onboard aircraft receivers that receive the radio frequencies transmitted from the threshold runway from the runway threshold antennas of the ILS localizer with the instrument landing system that transmits radio frequency from the radio transmitters of the ILS localizer and receives from the onboard antennas of the aircraft, and displays the horizontal localizer and the vertical glide slope. You can see here in the primary flight display. I'm going to show you later all the information as we proceed for takeoff and for of this flight for takeoff, flying cruises, and approach and landing. You're going to see the complete flight. So we have the ILS localizer of the runway 14 of Zurich International Airport in Switzerland, the Lszh airport, and we're going to use the ILS localizer frequency for that. The ILS localizer crossbus, the flight director crossbus for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and zero with the autopilot and the auto throttle. Later on, vertical navigation modes. We have also the navigation display. You can see the navigation display that displays the GPS position of the aircraft, the inertial reference position, the magnetic heading and track, the magnetic north pole and true north pole, and the magnetic variation depending on where we are in the world. You can see the horizontal vertical profile of the terrain displayed with red, green, and yellow color. Also, you can see other indications like how far above the terrain the aircraft is flying or how far away. We have also the display of the airports. The airport that we are located is Zurich International Airport with the 4-letter name. The runway we're gonna use for takeoff and for landing. The other runways of the airport and the taxiways with the GPS. And you can see the orientation, the magnetic north pole heading that we have selected right now, or the geographic north pole. And we're gonna use for takeoff and for landing. So you can see the runway length. You can see also the navigation aids, the voice stations, ADFs and DPs, the waypoints which are horizontal vertical navigation fixes. We have to fly through when we select them using the flight management computer. You will see the process over here. So we'll select using the flight management computer. You can see it over here. Look at it, look at this one. So I'm going to use the flight management computer to create a flight plan or a flight path or a route for this aircraft with all the data of the aircraft. Also is going to be used from the autopilot and flight director system panel, and the modes of the autopilot like the LNAV and the VNAV, with the lateral navigation and the vertical navigation modes of the autopilot and flight director system panel, and the auto throttle when we fly. You can manage the aircraft flight path, airspeed, and other data. Also, you will see these modes and the other modes that we have on the autopilot flight director system panel and the flight management computer. So you can see the navigation display, also the display of the waypoints, as I told you, the display of other aircraft. You can see other aircraft that fly around our own aircraft, how far away they are from our aircraft. We have the transponder, the DSP and AAC transmitter receiver that transmits our frequency to other aircraft and the air traffic control, and receives from other aircraft and displays using its computer. You can calculate how far away using the radio frequency. Calculations can calculate how far away the other aircraft are located, the altitude difference from our aircraft, whether they climb or descend with respect to our aircraft, and calculate also the speed between our aircraft and the other aircraft, and give us a warning we have an incoming collision in the air, using the TICA system, traffic collision advisory system, that is displayed in the primary flight display and the navigation display. So we have all these things about the navigation display. We have also the ACAS, the engine indication and crawler system display, also the engine's functions, the thrust levers, the flaps and the slats, the speed brakes, also the cockpit one by one, all the instruments. You see over here the flight controls, how to control the aircraft in the air using the yoke, how I can climb using the elevator to climb and descend, also make turns to the left or to the right. You see the input from the side stick. It's a fly-by-wire aircraft. I will have the rudder pedals also. So you will see all the systems that we have about this aircraft, the Boeing 787. You will see all the displays, the ACAS, the Edge Education Control System display, the Autopilot Flight Director System panel over here with the modes. You can see over here the primary flight display, the HSI, the radio management panel over here, the overhead panel. Over here you see the electric, hydraulics, primary flight control computers, air data computers, flight control surfaces, so electrical, hydraulics, fuel system, electronic engine control and auto start for the engines, and cabin pressurization, pressurizer over here system, bleeder system with the packs, and wing and engine RDIs. So you will see all the systems that we have, also cargo fire and APU fire, the engines also. You can see fuel control, for instance, left and right engine. Also you how to turn off and on the engines of the aircraft. So I will show you also the other systems that we have. The Autopilot Flight Director System panel. So you can see here, I will use the flight management computer to input all the data of the aircraft for this flight. So you will see that in a later part. Now I will show you the flight controls. I will show you the outside view. So I will talk to you about the Newton's physics, aeronautical and aerospace engineering, and show you some principles and equations we need for the air transport pilot license. Also the Bernoulli theory of fluids, aerodynamics. So you will see the flight dynamics principles. So you can see here we have the aircraft, the Boeing 787. You can see the wings of the aircraft, called the weight of the aircraft as the aircraft flies. You can see we have the thrust vectors from the engines that move the aircraft forward. We have the mean aerodynamic chord position, the Mach, which is 23% of the mean aerodynamic chord. This is where the maximum aerodynamic lift appears in the wings, also where the stall usually begins for a given angle of attack in flight. The airflow becomes detached all the way back from here. We have also over here the lateral axis from wingtip to wingtip. We have the vertical through the center of gravity is pretty much close where the mean aerodynamic chord is, the Mach of the aerodynamic chord. We have the longitudinal axis over here that transverses through the horizontal tail. So you can see the axis through the horizontal tail over here is for making the longitudinal axis to making turns to left and right using the ailerons and the spoilers around the longitudinal axis using the flight controls here. Flight control using the side stick. You can see we make turns over here. You can see through the vertical axis we have the yawing axis from the rudder. So we use the rudder to make turns like this. So I use again the side stick to control the rudder. So this gives the yaw runs through the center of gravity vertically. So this also gives the elevator for pitch up and pitch down around the lateral axis over here. You pitch up the nose or pitch down, again all through the center of gravity of the aircraft. So you can control the aircraft in flight, you can change its direction using the flight controls. So I will keep talking about the aerodynamics. Also we have the trim of the horizontal tail, the horizontal trim stabilizer over here. We can trim the horizontal tail surface up or down, adjust the elevator depending on the aircraft. So you can trim also the rudder. This relieves the air pressure from the flight controls when we use trimming. We trim using this trim switch inside the cockpit. I will show you later. So you see the wings, as I told you, they produce the aerodynamic lift. Also you can see the surface of the wings using the Bernoulli theory of fluids, Newton's physics. You can see the bottom surface of the wings is more flat, and we have the flaps extended, so they create a flatness over here. Also the aircraft will be having an angle of attack when it's flying. So using the Bernoulli theory of fluid, you can see the airflow is moving slower below the wings, so we have higher pressure, which pressurizes the aircraft wings and weight up into the air. So the top surface of the wings also we have more curvature. So using the Bernoulli theory of fluids, again the airflow is moving much faster above the wings, which creates lower air pressure, which sucks the aircraft weight up into the air and the wings also. So this is the main components of the aerodynamics you need to know for flying the aircraft. Also for the flight controls I use. So I will show you the flight controls now in a couple of seconds. How to control the flight controls. So I have the side stick to control the flight controls of the Boeing 787. For climb descent I use the elevator. Also the control column here. When I move the side stick, you can see the elevator moving up and down the horizontal tail over here. For climb descent, you can see the elevator moving up and down. This makes a climb descent. You see also control wheel over here, left and right turns. We use the control wheel section over here, so this makes the ailerons and the spoilers, the left and the right wing with the spoilers retracted. You can see maybe better the surface that we use for this to make turns, also using the ailerons and the spoilers. We have the rudder pedals also, as I told you, rudder pedals to control the vertical rudder over here. So you see the rudder pedals also. So the rudder pedals also have all other functions. So they also control over here. You can see the toe brakes using the rudder pedals. We have the nozzle steering. The tiller is interconnected for some aircraft in the rudder pedals. Until some airspeed in takeoff, like in 70 knots, is deactivated. Then we have only the rudder function from the rudder pedals. So it has a deflection like 76 degrees when we are having low airspeed, like 10 knots, 30 knots. Then it's decreasing until maybe 7 degrees from above 40 knots in takeoff, until 0 at 70, maybe 80 knots. So you can see here we can climb, descend, make turns in flight, use all the flight controls, nose steering in the ground over here. We have also the horizontal trim stabilizer, the pitch trim of the horizontal tail of the elevator of the aircraft of the Boeing 787. So you can see we can use that. Also here you can, as you fly, you use this pitch trim switch here. This gives nose down of the aircraft pitch, and this gives nose up. So you pitch down, pitch up like this. This way is pitch up. This way is pitch down. The left click. So you can see what it displays here. elevator trim, left click down, right click up. So you use the switch for trimming up the aircraft as you fly, the horizontal tail to trim the nose of the aircraft as you fly to balance with the aerodynamic forces. So you trim all the time. You can use also, we have a couple more switches here. We have the autopilot disconnect here. We have the head-up display, the clutter over here. We have some other switches I will show you later, and the indications here. The flaps limit, the multifunction display. So this for displaying these, changing the indications, switching the displays around. So so you will see here we can climb, descend, rudder pedals, the flight control computers over here, flight management computer and flight control computer. So when we move the side stick or the yoke in the Boeing 787, we control the flight control computers input. So you can see the flight control computers over here. It's a fly-by-wire aircraft. It should be in the auto position before takeoff. Primary flight control computers, switch guard over here. So you have to have it in the auto. You have the normal mode, the alternate mode, and maybe you have a backup mechanical mode, direct mode, like in the Airbus, but a little bit different. You can see both sides move together, the left and the right, the captain and the first officer. Unless we have a failure, all the flight controls are interconnected, the yoke, the control wheel and the rudder pedals. Also, they're not like in the Airbus. You have the side stick priority button for the captain or the first officer. You can use either side at the time you need. So you can see also for the flight controls, as I'm showing you right now, the horizontal trim stabilizer. Don't forget what is doing. Horizontal trim here, trimming up and trimming down like this. So you have also the effect over here in the horizontal elevator of the aircraft. When you fly, you trim up and you trim down the horizontal elevator for pitching up or pitching down the nose of the aircraft, of the Boeing 787. So also you can see, besides the horizontal trim stabilizer here, we have the autopilot flight director system panel, which has the automatic trim. Since this is a fly-by-wire aircraft, it has the auto trim function when it's flying to trim and balance itself using the flight management computer inputs, so the autopilot flight director system panel, the auto throw, and the flight control computers. So you will trim itself. You can, if you have a failure that affects the L2 or R2, the lateral horizontal or right horizontal, the left horizontal or right horizontal stabilizer. It can be seen here, the hydraulic system. You're gonna have a failure of the auto trim function from the autopilot flight director system panel. So you come over here, you see this red guarded switch over here next to the thrust levers in the pedestal. It says cut off stabilizer trim L2, the left horizontal and the right horizontal. So this is to cut off the horizontal trim stabilizer. From normal to cut off, it will disconnect the auto trim function. So you use the alternate over here if you need alternate pitch trim next to that also, which is a manual trim channel for the horizontal tail of the aircraft as you fly. So you trim the nose of the aircraft up as you fly, you trim the nose of the aircraft down this way. You have the parking brakes also. Over here you have the mouse pad, the flight management computer. I'll show you one by one all the instruments. So after you disconnect the horizontal trim function, You have only the manual trim over here again, only the manual trim channel. You lose the auto trim function, so you can see again. Elevator trim, so you trim like this manually after that. So this is for Boeing aircraft 737, 747, 757, 767, 777 and 787. The auto trim to disconnect switch for this function of the aircraft. So you see the stabilizer trim position over here in the ACAS engine indication controller system display. 4.25 degrees in the green band. You see the flaps position, you see the rudder trim, you see the left and the right engine indication function over here. I'll show you one by one all the instruments of the Boeing 787. So we have the functions here, the messaging, the warnings. So we have rudder trim, cabin altitude, rate of climb descent. This is the pressurization, differential pressure, landing altitude indications. So you'll see later. Gross weight of for takeoff 358.3 thousand pounds. Total fuel on board and the total the fuel temperature right now. So we need to heat up the fuel in flight so it won't freeze. So you will see that. So we have a few more things to see here. Also, we see the flaps and the slats, the handle, the speed brakes, the thrust levers. I will make the flight plan in a couple of minutes. Then we're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing. After then, we're gonna make an engine start demonstration and show you all the functions of the aircraft inside the cockpit, all the controls and systems. So I can show you here a couple more things. You can see the flaps here, this handle. So this retracts, we have them extended. Now it extends, so you can see how many degrees you want them. So you can see here. When we move the thrust levers forward, you can see the degrees, how many degrees you want them. So this is the flaps like 25, 20, 18, 17, 15, 10, 25, 30. So we have over here also the speed brakes, extend and retract. So you can see the speed brakes extend and retract. You can see the flaps are fully extended right now, 30 degrees. We're gonna use less than that for takeoff. So you can see how nice detail we have here of the aircraft. We can see we have also the display of the engines. As I told you, here next to it we have the landing gear. Over here extend and retract, now it's done. We have the standby instrument. We have the landing gear alternate if we have a failure of the normal, the lock override. Over here the auto brakes, rejected takeoff, RTO. You will see displays rejected takeoff now when we turn the switch. When we turn the other way, rejected. We have auto brakes 1, 2, 3. So you will see also that. So one of these is in the manual. I don't know why. Maybe we can turn off the pressurization here. You will see what it displays later, the cabin pressurization. So I will show you the engines also indications. So you see now it's showing some warnings because we turn off the switch from automatic to manual. Cabin altitude, outflow valve, aft and forward, FMC message, landing, altitude TCAS off. So you can see again the same like before concerning this. So I will show you also, as I told you, the autopilot flight director system panel, the displays, the thrust levers over here. So when we use the flight controls, as I told you, I will complete now the flight controls. We have also the yoke, climb the descent, with the control column for the elevator, irons and spoilers left and right, using control wheel or other pedals. We have also the flaps and the slots, the horizontal trim stabilizer, the thrust levers. Also you can see here the nose wheel steering and the thrust levers. You can see we can move the thrust levers like this. So I'll show you also another view of the flight controls of the Boeing 787. So you can see here we can climb and we can descend the aircraft. We can make turns to the right, turns to the left, the rudder pedals. So climb, descent. So you see the side stick I'm using for controlling the flight controls of the Boeing 787. You can see the deflection. The side stick deflection is proportional to the yoke. Both sides are interconnected. The rudder pedals, the horizontal trim stabilizer over here, and also the thrust levers. You can see here we use the thrust levers. The switch. You can see how much percent you need to move the thrust control forward or aft. So you can see, I hope you like the flight controls of the Boeing 787 over here. So we can climb, we can descend, we can make turns to the right, turns to the left, used later in the flight part. You can see also horizontal trim stabilizer. You can see also this view again, climb, descent, the elevator, the rudder pedals. Make turns to the left and the right. So spoilers are retracted. So I will show you now the rest of the systems of the Boeing 787 and 100jet aircraft. I will continue now with the thrust levers, the flight management computer. I will complete the flight plan. So I will input all the data of the aircraft for this flight. That includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing. In the center tank we have 30% in the left and the right wing and 10% in the center tank. The flight management computer is going to calculate the center of gravity of the aircraft for the flight from takeoff, climb, cruises, and approach and landing with burn fuel during flight. So it's going to be recalculated because it's shifted. Also, for the takeoff, it's going to give us a mean aerodynamic core position, 33% of the Mach, as I told you, using the center of gravity, and the horizontal tail trim stabilizer position, 4.25 degrees up. So nose up. So you will see also the flight management computer, I will input the takeoff and landing runways. So we're gonna use the Zurich International Airport, the Lszh in Switzerland. I'm gonna use the runway 14 in Zurich Airport for takeoff and for landing. So we're gonna have the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air and the temperature of the air, and also whether the runway size dry or wet is gonna give us for using. We're gonna use 15 degrees of flaps, 15 degrees of flap. And we're gonna use also 9 degrees of pitch attitude. In takeoff is gonna give us the takeoff speeds V1, V8 and V2. So I'm gonna show you how I'm gonna use the flight management computer. Also I'm gonna use the seats, the other instrument departure waypoints and fixes, and include horizontal and vertical navigation fixes for the initial takeoff of the aircraft, the initial flight, and airspeed and altitude constraints, the climb to the cruise level at 35, 36, 27, 28, 29, 30,000 feet above the sea level. Then we're gonna cruise through some waypoints. I'm gonna make some turns, then we're gonna come for descent back to the close to the airport elevation, like 7,000 or 6,000 feet above the sea level, and the airport is 1,430 feet with the runway. So we're gonna use the stars, the terminal arrival waypoints and fixes for the terminal approach and landing of the aircraft. We're gonna use the horizontal and vertical navigation fixes and airspeed and altitude constraints, the stars. You can see them also in the navigation display later. So we're gonna have the magnetic north pole heading of 136 degrees of the runway 14 in the Zurich International Airport in Switzerland for approach and landing, and we're gonna use the Lszh localizer, the instrument landing system for approach and landing with that. For horizontal localizer alignment and vertical glide slope with the Lszh localizer. Crossbars also we can tune the Lszh localizer here from the radio management panel. We can use the flight management computer automatically when we select the landing runway. So we're gonna have a complete flight plan from takeoff, climb, cruise, descent, approach and landing. So I will show you now control quadrant. So I set up a flight plan over here. So you can see we have also the mouse pad here, we have the flight management computer. So we're gonna use here the index. We can set anything we like here, like identity of the aircraft, position, performance, takeoff, approach, annunciate status, navigation data, flight plan, loaded traffic control, save plan, save flight plan. So we use identity. You see it's the model 787-900, the GNX engines. The position, we use the reference airport, the Lszh in Switzerland, and this gives us the coordinates, GPS coordinates, nearest one. Last position, GPS position. The index performance, so we use performance here, gross fuel, gross weight and fuel on board, zero fuel weight and fuel on board. The cruise altitude, first I'm gonna use the route from this airport, Lszh, back to this airport. So copy paste this. So you can see Lszh, back to Lszh, runway 14. We use the alphanumeric here, the keyboard, and we have the mouse. It's a touchscreen, and also we have the mouse pad in it. So we go back, initialize departure arrivals. So we use departure and arrivals for this airport, the Lszh. So we can select either runway 10, 14, 15, 14, 16, 28, 32, 34. So we're gonna select runway 14 for takeoff, Zwift to Alpha, the seats, the southern instrument departure waypoints and fixes. So we have the arrival here. You can set either one, VOM 16, 28, 34 runways, Lszh 14, Lszh 16, ILS-28, ILS-34, CLS-14, localizer 28, localizer 34. So this is the runways we have for gliding. So we're gonna use ILS-14 over here, ILS localizer, trans-amici, transition, and stars. We're gonna use the solar terminal arrival weapons and fixes from next page, Negria 1 Alpha. So you can see all the data that we have. Select this, the star terminal arrival weapons and fixes. So we have departure arrivals, we have the legs activated, we have an active route almost. It's waypoint, led by waypoint from takeoff, climb, cruise, descent, approach, and landing. It's gonna be the flight plan. You will see in the navigation display later displayed. We have to cross through these runways. We have to cross through these waypoints with the airspeeds and the altitude during flight. So we need to activate that 5% reserves, 0 fuel weight, 332.7 thousand pounds fuel on board, 34,700 gross weight, 57.4 thousand pounds. Cruising altitude 35,300, cost index 100%, fuel cruising, fuel freezing temperature is gonna be minus 37 degrees in flight, so we need to heat the fuel in flight. Cruising center of gravity 28% reserves. So you see the calculations are made automatically. So if we execute it now, you see the legs are gonna be activated with a purple here. The first one, waypoint, 2 nautical miles, the heading of the runway, 135 degrees, 250 knots, 1900. Then the second one, TRO 96, 1 nautical miles, 250, 2500. Intercept, we change direction here. Zui, 6 nautical miles, after 134, 9, 10, 11, it's gonna be like 17 nautical miles away. 300 knots, 6000 alpha. Then we climbed Negria 071, we changed direction again. 26 nautical miles, 300 knots, flight level 22,200, Mative 230 degrees, we changed direction, make right turn. 12 nautical miles, 320 knots, 11,800, Amici. So you see one by one the waypoints, 190 knots, 6 nautical miles, 10,400, Zui 276 degrees, 9 nautical miles, 187,000 alpha, Z8701, 186,000 alpha, TRA 180 knots, 5,000 alpha, C I14 180 knots, 4,000 alpha, Osnem 170 knots, 4,000, runway 14 140, 1,400, 55. So this is a complete flight plan. The flaps for takeoff I'm gonna use here is gonna give us the takeoff speeds, center of gravity with the trim automatic. It's gonna be 23%. Over here, CG trim, and the takeoff speeds V1, V-rotate, V2 with the gross weight, runway position, request, index. So we can use also other functions, the fix over here, the hold. We can hold using a waypoint, departure arrivals, alternate, VNAV, progress, FMC communications, the hold again, fix, and navigation radio. So this is the flight plan created. Over here we can go in the virtual cockpit. You will see again we have the flight plan displayed here in the navigation display, in the primary flight display. So you will see how I'm gonna use this information, the displays. I'm gonna show you also the autopilot flight director system panel. I will set the autopilot values now. So you will see the autopilot flight director system panel over here. So you can see the displays. What they display, you can see we have the barometric pressure, altitude set here, baro set, inches of mercury or hectopascals. The displays the range plan, minimums, radio, some warnings, alternate, cancel, reject. We have the weather radar over here, WXR, traffic and the terrain, all this displayed here, and the barometric altitude here for the altitude display. So you will see all these things. You can see also all the air data. We have pitot static, pitot dynamic, airspeed, altitude, GPS position, magnetic, north pole heading, or are displayed using the air data computer here. Also the laser gyroscopes, the GPS receivers, 2 or 3 GPS receivers, gyroscopic alignment, laser gyros for the attitude of the aircraft. So pitot airspeed, pitot dynamic, and pitot static for the altitude, and the rate of climb descent or from radio altitude, angle of attack of the aircraft as it flies. So you can see also the navigation aids now. We have the range here. You can change. You will see also the display, the mouse pad. So you can see the GPS position. We are positioned over here in the airport. You can see we have the taxiway in front of us, so the runway we're gonna use for takeoff and for landing. The other runway, you can see the terrain, the elevation for this range over here. Half nautical mile right now. You can see the terrain. Also, when you're flying the aircraft, you will see how far above the terrain. You will see this triangle is the aircraft. We're gonna be flying like 3, 4, 5,000. We're gonna have the terrain below us in the radar display. So you see the runway over here, the one next to us, and the taxiway. It's like here in the display. Also from the outside view, you can see in the mountains that we have, and the runway and the taxiway. So you will see them displayed here in the navigation display. Also in the HSI, the horizontal situation indicator. We have the flight plan for takeoff, climb, cruise, descent, approach and landing. All the waypoints we have selected over here in the flight management computer. As you can see, we need for navigation. So you can see also you can change the range. You can see further away other airports. You can see the Germany here, the France further away. So here is Germany, here is France, here is Switzerland down here. This is the display. So you see we're gonna be flying through these waypoints closer to us. Over here you can see the purple or magenta color. So this is for approach and landing this way. This is for takeoff using this runway. Also the slope and how far above the ground we're gonna be flying over here. The climb slope over here. The vertical profile actually, and the horizontal profile of the flight plan. So maybe we can see a little bit better if I change our range over here. Maybe if I use the center also, but still it's too much clutter. You can see further away Amity waypoint. We have used Negria over here, Mati. So you will see all the waypoints in the end and how far away we are displayed. Also the vertical, as I told you, you have to fly through all these waypoints and the vertical profile. You cannot change the altitude set. So a couple more things. The plan over here. Map centering. So we have the flight plan here also. The terrain with red, green and yellow as I told you. The aircraft symbol. So we have also the engines, the left and right engine indication. The ACAS, you can see the N1. I will talk to you about now. It's the low speed starter sub, low pressure compressor into one of the turbofan towards the engine, left and right. 19.8% idle, exhaust gas temperature per engine. The N2, which is the high speed starter shaft, the high pressure compressor into one of the turbofan towards the engine. The takeoff limit 99.5%, the red, green, yellow limits. So you can see the fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So So also you have a few more systems. You can see the thrust levers when we move around. We have the auto throttle over here, disconnect also for the left and right engine, both engines. Takeoff, go around, thrust reverse, pull up this for slowing down the aircraft in the ground, in the runway. We have also some other displays here. You will see systems display, you will see autopilot, flight director system panel. So I will change some modes displayed. You can see autopilot engage and disengage switch here. The airspeed, we're gonna set the airspeed for takeoff. So we can set either like this, you can set less value than this, like this, or more, how many knots you want. So we're gonna use this for takeoff. We have the auto throttle left and right. So this is the airspeed guidance, the LNAV with the VNAV, flight level change, climb continuous, auto throttle, autopilot disengage and autopilot engage. Also we have LNAV, VNAV as I told you, flight director off, it disarms the mode's armament. You cannot rearm with the flight director, this switch needs to be on. So it turns back on the function. So we turn auto throttle off, autopilot disengage here. We have heading over here, bank angle in flight. Heading, we're gonna select the heading of the runway. I'm gonna use for takeoff 136 degrees. The altitude, we're gonna use 35,000. 300. We have the roll localizer also, approach throttle and hold vertical speed over here. So we're gonna use vertical speed. If we press this switch, you can use zeros, you can descend, you will see the minus sign. You can climb using this roller, this slider, you can move it up. So now you have the climb rate here, class. So it will display here in the primary flight display the indications that we need. 253 knots. So you see the airspeed indicated over here. The barometric altitude, as I told you, the vertical rate of climb descent of the aircraft 10,000 feet per minute, the vertical speed indicator, the pitch altitude 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20, pitch up or pitch down, the bank angle as we fly, flight mode on 0, angle of attack, radio altitude above ground level. So I'm gonna set a few more things now. I'm gonna start the engines. I'm gonna make the engine start demonstration also in the last thing before takeoff. So we need to set here the APU on for making an engine start demonstration. You can see the left and the right IDG, the great charge generator, the battery, 120 to 100 volts, 400 trace rated, left and right engine driver, primary flight control computers at the auto position, air data, heading reference, flight control surfaces, FT door power, downwind power, passenger oxygen over here, window heat. We have the ram air turbine, we have the left and right hydraulic engine driving. So we turn off, you will see what happens. We get this warning over here, so we turn back on. Demand the primary, we have the electric also standby. We have the wing and engine ADIs here, as you can see. We have the fuel systems. You will see first the recorders over here, the cargo and APU fire, electronic engine control for the engine with the auto start over here, the normal and the alternate mode of the engine, auto start. I'm gonna use it in 1 minute. We can dump some fuel in flight to lose weight, to make an emergency landing. If we arm this and select the nozzles, fuel booster pumps, left and right wing fuel tank, center tank, crossfeed valve. So if we turn the crossfeed valve, we can feed either engine with either pump or either tank, or balance the fuel between the left and right wing. So we have all these things. You can see also lighting system here, windshield wipers. We have the pressurizer, the bleeder from left to right engine. Also cabin pressurization here. Manual, we use the outflow valve, so carbon and descent. Auto, we use this way, automatic. So now the last thing, before doing the engine start demonstration, we have to see the display of the systems over here in the digital format. So you will see the digital format display systems. You will see we have the hydraulics here, APU, oxygen, liquid cooling. The first page, electric. You can see the left and the right engine drive and IDZ. The contactors are on 120 to 200 volts, 400 Hz frequency. The APU is running. Main battery voltage and APU battery. Over here the load cell. So we have the hydraulics over here. You can see where the hydraulic fluid goes over here, which is in use. The left engine driving, right engine driving, electric C1 and C2. Set of valves, and also the pressure of the system 5100 psi. It's left right engine driving. So we have the fuel, left and right wing fuel tank, center tank, left right wing, center tank. Over here you can see the left and right engine, low and high pressure fuel valves are open and feed both engines from the center tank or the left and right wing. We have the APU, it's fed from the left wing with this motor. The crossfeed valve is off, but we turn it on. You can feed either engine with either pump or either tank or balance the fuel. So we have 11,000 and 11,000 left and right wings, center tank another 11, total 33,900. So you can see also the minimum fuel temperature here. We need to recirculate the fuel in flight, so when freeze is automatically recirculated using the FAREX. The FAREX are full authority. These electronic control computers, one installed per engine gearbox. I'll talk to you about in a couple of seconds after the engine's indications. So we recirculate the fuel. We have the air system, pressurizer, the parts left and right. The doors are closed, the cabin can pressurize, the landing gear, the pressure of the tires and the temperature of the brakes, nose wheel, flight controls here. You can see left and right. Over here the elevator for climb, descent, also rudder pedals. So we have also LPG display, maintenance, circuit breakers over here. So we go back. We have also the checklist over here. Last thing to see, normal before takeoff, what to do after takeoff, descent, approach and landing. So we go back in the navigation display. We turn off both engines like this. So you can see the engines are decreasing, the engine power, also the hydraulics are retracted. So we go for the engine start now. We need to go here in the overhead and start the starters automatically. Auto start, as you can see. You can see all the yellow indications here. So you see the pressure is above 20%. In the N2 we have pressurizer from the APU. You can hear also, you can see. So we start the engines over here, both fuel control. So we have the auto start is on, 28, 24, 36, 37. So we have the engines, pressure is increasing, and we're ready for takeoff. Auto start, we need only running engines over here. So we have running 62, 64 now %. So we use flaps for takeoff, 15 degrees, and we advance the thrust levers, parking brakes off. So we take the run with clearance over here. So we advance the thrust levers to full takeoff power over here, as you can see. We press the yoke a little bit forward, so we have the takeoff power set, 80 knots, 90, 100, 120, 130. So we have V1, we rotate over here, so we rotate, use the rudder pedals also to align. So we make 9 degrees of pitch attitude for rotation. We have positive rate of climb, so we retract the landing gear. So we have 15 more minutes left for this flight. So we keep climbing over here. You can see we are more than 2,500 feet above the ground, 4,600 above the sea level. You can see the airspeed 108 knots, the pitch altitude 20 degrees. We can pitch down a little bit. The stall speed also, the wind direction and speed. So we have the flight plan here, the indications from the engines also. So we keep climbing. You can see how far above the ground we are, almost 4,000 feet over here is the aircraft above the ground. The green is the terrain below us. So you can see we can climb up higher, so I'm gonna do that. You can see also the terrain, yellow, green, red colors, the engines, and the flight line we need to follow. So one more view outside as we climb out from the airport from Switzerland. So we have a beautiful view of the Switzerland, of Zurich over here. So we're gonna start the turn now. Use a little bit left rudder. So we keep climbing. You can see the airspeed right now, the altitude we're flying. So maybe we retract some flaps. We're gonna fly a little bit faster airspeed, but it's gonna decrease the rate of climb. So you can see we can fly with the hands off like this. You can see the aircraft, also the cockpit after takeoff. So maybe we're gonna increase the airspeed. You can see now we are very close to the stall speed here, the yellow and the red marking our airspeed, but we're gonna increase the airspeed a lot. as we fly without flaps. So you can see where we're flying right now. Beautiful view. The lake here, the Germany, the France, the galaxy above us. This is the Boeing 787. So we're gonna make some turns now to align with the flight plan. With 10 more minutes to go back to the airport. As you can see, we're following the flight plan here we have created. You can see the flight plan again, the indications, autopilot flight director system panel, the audio display. So keep climbing. We need a couple more minutes to start the turn. So we're gonna be overflying the lake here in the Switzerland, the Germany, my homeland, the Bayern Munich, the star sign, and the France here. Beautiful star sign with the aircraft. The Boeing 787. As you can see, we are overflying this altitude now over here. So we're gonna make a turn now. Come back for the airport as we climb. So we take the turn, as you can see, back to the airport. Use a little bit right rudder. So you can see here the turn. We are overflying the lake and the Germany behind us, the Bayern Munich and the France. So beautiful lake here. So make the turn, and we're gonna have the chemtrails in a couple of seconds, and we need 8 more minutes to get back home. So we're gonna start flaps retract, increase the airspeed like this. So we're leveling off here, as you can see, manual level off. So we are flying here. We're gonna be having the chemtrails now coming off the aircraft. So here we are, we have the chemtrails, the frozen vapors, as you can see. So hope you like this view of the aircraft, of the Boeing 787, as we're flying with the frozen vapors effect, the galaxy above us, and the lake behind us over here. We're gonna make now the turn for the airport, back to the airport. So we need to start the descent now. We have 6 more minutes left for descent and approach. So begin the descent of the aircraft. As you can see, this is the descent now, back to the airport. So we're gonna increase the airspeed like this, and we have 5 more minutes left for approach and landing. So we need to increase the rate of descent. You can see the airport here, the blinking lights. We can see it also in the displays over here. Where is the airport, the runways, and we are here right now. We need to cross through the waypoints as we descend. So we have 4 more minutes left for the approach and landing. You can see that we are descending, so the view of the cockpit. Need to cross through all these waypoints here. So we're gonna start the turn now for the approach and landing. As you can see, as we keep descending. So we're having the turn here for the approach and landing. Manual turn again, and we have 3 more minutes left for approach and landing, as you can see. Need to descend a little bit lower, increase the rate of descent. And also to be aligned with the runway here, heading. So we have the heading of the runway. We have 2 more minutes left for approach and landing to the airport. So we need to increase again the airspeed, because we're gonna be off time for the record for 2 more minutes. So we align with the runway. We have some wind gusts here. Some flaps extended. You can see we are approaching over here. We need 1 more minute to get to the runway, so we're gonna have this nicer view over here. increase again the airspeed. So you can see we are aligned with the runway here. We can have the ILS localizer indication also, all the indications of the ILS localizer, the instruments are following. So we have some side wind, we need to combat the side wind from time to time as we are approaching full landing. Over here we have 10 more seconds. We're gonna land on time, combat the wind cast, the side wind, and align with the runway. So we're gonna make it here for the touchdown, as you can see. Touchdown, beautiful touchdown. Parking brakes and thrust reverser, idle thrust, thrust reverse. So made a very beautiful landing, idle thrust and thrust reverse.